So hopefully this explains a little bit of this line, house range equals new house. I make this mistake all the time. I forget to type these empty parentheses, which basically say the house is created and doesn't require any parameters at the time of creation. I always make this mistake because in C++, those parentheses there may be optional when you use C++ syntax. In Java, they are required. Okay, so in C++ they're optional. In Java, they're required. So I sometimes forget to use them, and I'm giving this error, and I'm looking at the error from the compiler and think, I've done very, very basic things. What can be wrong? And oftentimes I forget those empty parentheses, and that gives me an error. All right. So, but now let's examine the class name house. So in software, the house's declaration or definition, we'll name it that way, includes public, which means that it's for everybody's use, just like this. Even outside of this package class demo, someone should be able to say new house and capture its reference and start using it. So that's why it says public right here. If it was private, more restrictions would be, would exist on the creation of this house elsewhere in the program. But that's not the case, and most classes are declared public. So we have the house. Very, very important is to remember the opening brace, and of course there's a closing brace right at the end. And my style is to tag the last line, the closing brace, with the name of the class. Because basically tells me this is what I'm doing on this line. As you can see, there are many other opening and closing braces in this file. So this kind of have a special role that it actually closes the entire class, the scope of the class, the declaration of the class. So what happens inside is that I have those two data attributes, and I already tried to show you the way I picture them in memory, right? They're part of this box, and both of them exist. Now, if I repeat this line new, that means that, for instance, let me demonstrate this right away. Right, so I could Control-C, copy this elsewhere, and say, I don't know, shed, right? New house, right? So I could create a variable named shed and name it and create new house, and so this will be another variable. So look, in memory, what's going to happen when I say new? Every time I say new, this brand new box is created, right? So and again, my purpose to use like 3D box and not just a square on this particular drawing is to show you that those are actual physical things that exist in memory, that they do take resource away from the computer, and they really do exist, right? So there will be brand new house type of object instantiated, and the reference again will be captured by the program, and in this case retained by the variable name shed. But regardless, so now I have two objects. Regardless to whether whichever way I name them, they both are the house type of object. So they're exactly the same. And so now I could again copy and say shed, right? Set type I don't know, utility structure, whatever. So now from this point on, obviously what's going to be stored inside of these two objects is going to be different, right? Because this one will be remembering that it's a range type of house. This one will be remembering that it's a utility structure. This diagram, by the way, is somewhat oversimplified, and I should have started count here. This is somewhat oversimplified because what happens is the string is an object of its own, and it's actually the string. If this was a string, and this was also a string. What happens is that strings are instantiated as separate type of object, and we will discuss that when we start talking about Java types. So this is the true picture of what's going on in memory, because string right here, string name type inside class house, is actually an object of its own, and it gets created separately. It gets created, it gets allocated automatically, and we'll talk about it, soon. Perhaps this week we're going to start talking about strings in our Java class. Just to kind of let you know that things can be more complicated when our objects include our objects, include other objects, and string is part of an object. So this is what we say data attributes. But there could also be operations, and a very typical type of operation is a getter and setter, which provides access to classes' data attributes. Simply put, we can explicitly say that this is private, that we want to protect our data, as we discussed in our first week, and say that the class should perhaps protect all the data that it wants to keep, and provide enough methods or operations to manipulate the data. There will be a lot of benefits, by using this approach and and providing those methods. So the methods are, so far, that we have is set square feet, get square feet, set type, and get type. The method begins with the name, or actually contains the name. It has, how does compiler know that this is a method and not another type of variable? The answer is because of these parentheses. Data attributes cannot have parentheses. Only methods can have parentheses in their syntax, in their signature, when we try to put together a definition of our class. So simply by seeing this first parentheses in our code, compiler knows, okay, set square feet is a method, right? So it can have some input parameters, which just makes sense. Because when we want to set the footage of this particular structure, we have to pass some kind of a number to this method. So this 1500 is going to be picked up by this variable int feet, which is an integer, and will be used to store this value in our class. So it gets stored. If this was the original thing, so this is exactly where 1500 will be stored. Then this method will return, and we're going to be executing the next line of code right here. Okay? So this is first method that we created, and we simply say that this method is useful to set a particular value inside of our box in terms of what's the square footage is. The next method is named get square feet. It's kind of silly to use this empty set of parentheses, and you should sense already that those empty sets of parentheses, like here and here, we'll be using them a lot because they're really part of the syntax, and you will see a lot of empty parentheses around almost any programming language that exists today and people use. And so in all of them, or majority of them, uses parentheses to describe method calls or member function calls in C++, methods in Java, and member function calls in C++. So using empty set of parentheses here simply tells the compiler get square feet is a method, which obviously doesn't take any parameters, but still it's a method. Now this particular get square feet method returns back an integer, returns back a number. Not a surprise, because square feet is a number stored internally. So this method should return back, using the return statement, should return back exactly that. It's very straightforward, one line of code, and we're done. Set square feet method, on the other hand, is not does not intend to return anything back. And to mention that fact and to tell the compiler that do not accept any attempts to use this method to extract a value from our class, from our object. Just we say it's a void. Void is a keyword, reserved word, that basically says this particular method can be called, but you cannot expect it to return any value back. For example, I could say int area equals range, if I can type, range get square feet, right? So get square feet is something that I can do to retrieve the footage of this particular property named range. On the other hand, if I attempted the same thing by saying set square feet, not that I'm making multiple mistakes here. First of all, set square feet requires some value. Okay, I could provide some dummy value like 0. Okay, all right, but still I cannot return an area from this method because it doesn't return anything, because it says void. I am not returning anything back. Okay, so really this is a mistake, and this should probably be doing this, right? Just get square feet, not set square feet, and then you can return back a value.